Okay, this is a tutorial based upon the aerial photo interpretation and digital airborne imagery training that's been run by Scientific Services, and we'll be talking about in this tutorial digital airborne imaging, specifically the acquisition of digital imaging. The entire tutorial will cover a range of different issues. First of all, acquisition, as I've just mentioned. We'll also be talking about product and availability. We'll be talking about viewing options, digital airborne imagery versus Spot 5, specifications and definitions of digital airborne imagery, specifications, use and a demonstration of the planar system, ADS-40 bits and pieces, a note about LiDAR, and a summary. So in this particular tut, let's talk about acquisition. Now the ADS-40 imagery is gathered by a sensor that has more in common with satellite imagery than the traditional frame-based aerial photography that we're used to. This is what it looks like. You'll be aware that traditional imagery is captured by a sequential taking of a photograph with about a 60% forward overlap and about a 20% side overlap. The plane then turns around, comes back and repeats the imagery and builds up a mosaic of images over a map sheet area. With the ADS-40 sensor, it has a sensor with three angles of view: a forward 28 degrees, a vertical nadir and a backward 14 degrees, each collecting different bands of information from the optical light spectrum. The forward is a panchromatic only sensor, which is a slightly finer resolution than the other two sensors and can be used to pan sharpen the other data. The nadir sensor has a range of bands from the near infrared, blue-green-red, and a couple of panchromatic bands. And the backward sensor has an infrared, blue-green-red, and a panchromatic band as well. And it's from these back two sensors of the three that we gain our ADS-40 imagery. The swathes are flown generally north-south as opposed to photo runs, which generally used to be flown east-west. We use the term swathe because it's like a broom sweeping across the landscape, picking up line by line. Each line can be from 10 to 80 centimetres of forward motion of the aircraft. To fly the 10 centimetre imagery, the plane has to fly lower and slower, and the 80 centimetre imagery can be higher and faster. This is a swathe of information that's been pulled into ArcGIS. This is how it displays a single swathe. The yellow box around the outside indicates that it is the active or selected swathe, and it will be displaying in the stereo window, which we'll talk about more in later sections of this talk. The two adjacent swathes will show up, one outlined in red, one outlined in yellow, the yellow being the active swathe. Aerial images photos are 8-bit red, green, blue, or black and white. ADS-40 images are co-registered 12-bit red, green, blue, plus an infrared band and a panchromatic band. This means that there's no misregistration of information in the different bands between pixels. All the information comes back from the ground surface, is put through a beam splitter, and the appropriate part of the wavelength of the spectrum goes to the appropriate sensor head. This means that it reduces any possibility of misalignment of the information. The system records position and altitude information in a mass memory unit as it flies. Putting into that mass memory unit is a GPS sensor and also an inertial motion unit, which it can help adjust for the motion of the plane as it moves around through buffeting, turbulence and such. This can all be subtracted from the imagery in post-processing to produce a smooth swathe of information. As I said, the stereo images are created using autocorrelation from the nadir and backward 14 degree sensors on the unit, and autocorrelation is basically a process where from 2 points in space an individual pixel can be aligned in both its X, Y and Z coordinate locations to place it in space if the position of the sensor is known accurately. Standard coverage at the moment by LPI, who supplies information to us, is 50 GSD, which is 50 centimetre ground sampling distance. As I said, from 10 centimetre to 80 centimetres is available. And the 3D use requires an extension for ArcGIS called Stereo Analyst, or can be used in like a photogrammetry suite or other software like ERDAS in 3D mode if the licenses are available. Basically, the use of Stereo Analyst enables us to view it in 3D and use the ArcGIS tools to be able to digitise over it and create data and use it for mapping purposes. Areas will be revisited every 4 to 5 years, similarly to the frame photography, and that ends the section on acquisition of ADS-40 imagery. Okay, moving on, we're now going to start to talk about products and availability of ADS-40 imagery. First of all, the data is provided to us in 3 formats from LPI, it's now called, Land and Property Information Office in Bathurst. That comes in as RAW at level 1 and level 2 formats. The RAW is something we don't use. The level 1 is georeferenced data that we actually use in the stereoscopic window in Stereo Analyst in ArcGIS. And the level 2 format is a mosaicked image which is auto-rectified and can be used as a map accurate backdrop in ArcGIS. The georeferenced level 1 data can be viewed using things like a planar viewing system. It can be viewed in anaglyph mode, which uses red cyan glasses on a normal computer, or it can be viewed in side-by-side mode on a normal computer. This is an actual example of an anaglyph image. If you have access to a pair of red-green anaglyph glasses, you can put them on. Left lens is red, right lens is cyan, and you'll actually see this image in 3 dimensions. Okay. The level 2 data, as I said, is 2D. It provides an auto-rectified layer at high resolution. The difference between the two can be simplified in this diagram, whereas you can see in this particular image at the lower left there is a skewness to the building that's visible in the image, and if you look at the right, it's been rectified so that the skewness has been removed from it, and it can be overlaid on a map, and points on the photo will line up accurately with points on the map. I'll talk more later about auto-rectification versus georeferencing. This was an example of good use of level 2 information. This is an area in the northwest of the state where the cap and pipe divorce program has been running kilometre after kilometre of pipe work to carry bore water to minimise evaporation losses and such. And the ADS-40 imagery enabled the people who were planning the alignment of the pipe work to more accurately plot the process through fences and gates, and to avoid areas of rocky knobs and sandy soils and things like that, which has produced a massive decrease in the cost of implementation and a massive saving to the landholders. That concludes the section on products and availability.